All right, in this video, we're going to look at independent events and their probabilities. First of all, let's just write down the definition of independent events. So here's the definition. Two events are independent if and only if the occurrence of one event does not affect the other. Okay, so let's look at this next question. All right, the question is, so we have a jar, and there are some yellow marbles and some green marbles. Okay, the question is, okay, if you pick a marble, then replace it does the second marble pick depend on the first? Okay, so this is known as a replacement problem. So when you see the word replace, we're dealing with a replacement problem. So let's say we find the probability of selecting a yellow marble here. The probability of yellow. Well, that would be 3 out of 5. Okay, but we put the yellow one back in there. So if we put the yellow one back in there, there are still going to be 5 marbles in the bag with the same ratio of yellow to green. So the probability of selecting a green, if you put it back in there, would not be affected. However, if you did not replace, the probabilities would be totally different. Okay, so this would be an independent probability. So this would be known as independent. Okay, so if you put the marble back in the jar or bag, it does not depend on your pick if you put it back in there and you replace it. However, if you did not replace or keep it out, then it is a dependent event. Okay, sometimes known as conditional. All right, so let's look at an example of an independent event here. Okay. Before we look at an example, let me give you the definition of if two events are independent. You can know this formula here. So if we already know the events are independent, we can do this formula here. So if I want to find the probability of event A and B happening, that's just the probability of A times the probability of B. Very, very good. If we know that the events are independent, we can use this idea. Just multiply the event A times the event B. So here's a question. Let's say question is, what is the probability and abbreviate that, of rolling a 2, what's this, six-sided die here, six-sided die, and flipping a heads. Okay, and this is a two-sided. This is just a regular old coin. Okay, so there's just a regular coin for the heads or tails. Two possibilities. The question is, what is the probability of rolling a 2 on a six-sided die and flipping a heads on a regular fair coin? First thing we need to ask ourselves, are these independent events? If you roll a 2, would it affect the flipping of a coin or vice versa? No. So these are independent events. So we can use our formula. A and B, that's just the probability of A times the probability of B. The probability of event A is going to be 1 out of 6, because my desired event is rolling a 2 and there's 6 possibilities. So 1 out of 6 times event B, my desired event is heads and there's 2 possibilities. So it'll be 1 out of 2. So this, if I multiply these together, my probability is just 1 over 12. Okay. Let's look at a complex problem here. Okay, so Alex can't decide on a shirt. So he chooses at random. Okay, and he has 2 yellow, 1 blue, and 1 green. Okay. We also know that the probability of rain is 2/5 chance, which is 40%. Okay, so this is what we're given in the problem. Okay, so here's all of his shirts, combinations, and the probability of rain. Okay, so let's answer this question. What is the probability that he chooses a yellow shirt and it does not rain? Okay, so these events are independent of each other. Choosing a shirt does not increase or decrease the chance of rain, or raining does not increase or decrease his possibility of choosing one of those 4 shirt colors. Okay. Now, if there was a jacket or a raincoat, maybe that might depend. But these are just 4 just regular old t-shirts. Okay. So these are independent of each other. Let's find the probability of that shirt first. So probability of that yellow shirt is my desired over my total possibilities. There's 2 yellow out of 4 shirts. So 2 out of 4, which is 1/2. Okay. Now let's figure out the probability of not raining. So probability of not rain. Okay. So this is like the complement of raining. So let's just find the probability of rain first. Okay, this is what we want, but we need to kind of go backwards a little bit here. So the probability of rain is 2/5. Okay. So we need to do the complement. So we need the complement of rain, which is not rain. So remember, we can do 1 minus our probability, in this case of rain, to find the probability of not rain. So 1 minus 2/5, well, when we do a common denominator of 5, will be 3/5. Okay? So now we have, so that's not rain will be 3/5. So that's going to be 3/5 there. So let's just answer the question now. So the probability of yellow, which we found was 1/2. The probability of not rain was 3/5. So these are independent events. All we're going to have to do is probability of y times probability of not rain, and that's going to equal 1/2 times 3/5, which is 3/10, or 30% chance. Okay, so that's going to solve that problem there. All right, let's see if we have some time for one more.